All right, I want to talk about particle lag. Particles are not free. Get a share screen going here. So particles are not free. They are less expensive than rendering actual mesh objects, but they're not free by any means. One nice tool from the standard assets utility is a frame rate counter. Find this under standard assets utility prefabs frame rate counter. And you can drop this in any scene and it adds a canvas and a text that will run this script and give you an average of the frame rate over some interval. To truly see the effects of lag, I want to turn off something called the VSync. And the VSync is a feature of Unity that throttles the frame rate to a nominal 60 frames per second. This is chosen because this is the natural refresh rate of most screens. I guess there's some that go higher. This is done in the quality settings under Edit, Project Settings, Quality, where you look down for the VSync count, which by default is every V blank. This synchronizes with every vertical refresh of the screen. Other settings include every second V blank and the one that we want, which is don't sync, which does not synchronize at all. An artifact of this is there can be tearing artifacts in your scene. In the documentation, it talks about this. It talks about how the Unity's updates are not necessarily synchronized with the display. So it's possible that Unity might issue a new frame while the display is still rendering the previous one. And this can result in this visual artifact, sometimes called tearing. That you have kind of a mixture of two different frames being displayed. So the VSync will synchronize the frame switches with the device's vertical blank or refresh of the screen. This will make things work better generally without these artifacts. But we want to turn that off so we can actually see the raw frame rate. One of the scenes in here is a particle lag scene that generates 200,000 particles that fall under gravity. And I modified the FPS counter script so that it outputs this information to a file that I can then plot. The main changes here are this right line where it's actually outputting things to the disk. There is a little trick that particle count comes from another script, ParticleCounter.currentCount. This is a public static scripts that are in the same folder with static variables have access to each other's static. More on that later when we get to scripting. So the result of this, it starts off with a frame rate of 120 some, decreases down to about 30,000, well, starts decreasing at about 30,000, has this funny plateau and then continues on down. And I believe this was done on my older computer. The newer computer is much faster and doesn't display the same behavior. Your behavior will be different. This information is deposited in a file that I believe is called it's deposited in a file here, frame rate versus particle data. This is the information that has the frame rate as a function of number of particles. So I'm not going to show that one because it takes a long time to run, but I will show you some other things here. In particular, I want to show you the effect of collisions, because collisions turns out to be the really expensive part of particles. I'll show you some examples with a simple geometry, a plane using the plane setting, a simple geometry using the world setting, and then collisions on actual terrains, flat terrain and one with a hole. And I'll show you the different quality settings of the high, medium, and low quality settings of the world collision and the impact that it has on our behavior. Collisions with simple geometries allow upwards of 10,000 particles without significant lags, whereas collisions with terrains seem to lag even at 1,000 particles. And the thing we'll notice is with these medium and low quality settings that the terrains leak particles while improving the performance, but they're not as rigorous about catching everything that hits it. I'll also point you at an explosions example where I've designed a complex particle effect to use as the projectile of a cannon. We're using a mesh sphere as the particle. We have various sub-emitters for tail and a fireball explosion for when it collides with something. The reason we might use a particle system for a gun's projectile is because particles are less expensive than instantiating physical objects. And I do have an object gun and a particle gun and scenes to compare them. And if you look at the profile of view, you can see the impact of the different systems. Way back with the particle systems, I mentioned that in the collision module, there was the option to send collision messages. And I actually used this in the particle gun to keep track of how many particles had hit the object at the end of the scene. And this is done by checking the send collision messages, and then in a hit by particle script, the on-particle collision keeps track of how many things have hit it. You could, of course, use this in your script to damage your player when it gets hit by a particle bullet. So let me just quickly show you these things. We have a flat plane collider here, 10,000 particles, frame rates up around 150. If I go back to a world collider, now the frame rate, you notice, is significantly lower in the 80s. Still good enough that the VSync wouldn't notice it, but this is a new computer. On a terrain with high quality collisions, and I've got this little window down here so that we can see the effect of leakage. With only 1,000 particles, I've dropped below that 60 frame per second limit with the high quality collisions. M is what's going back to the, with the medium setting, what we're going to see is occasional leakage here as the particles leak through the flat plane. And but notice this with a hole. Here I have a depression in my terrain, and the particles are bouncing around and rolling into the hole. And again, my frame rate with 1,000 particles has dropped below that 60 limit that the VSync would have imposed. And the effect of the lower quality settings is much more pronounced now with the hole. You can see lots of stuff leaking through my terrain, but my frame rate is maintaining a considerably higher level. The tilted plane collider here, this is a simple geometry where it's using the plane to do the collisions. This will run up to, I think, 20,000 particles without significant lag. But notice it doesn't fall off the edge of the plane. That's because the geometry is an infinite plane in all directions here. If I do this with a world collider, I'm going to see more significant lag as it collides with this simple geometry. We've dropped down below 100 here already with just 12,000 particles. But of course, it now behaves the way I want it to. It now falls off the edge of the plane here, but my frame rate's about half what it was with the other one. Here's an object gun. So these are firing actual mesh objects that are instantiated. We'll get to that later. But here's a particle gun firing particles. As it stands here, the frame rates are not significantly different. And then here's my example of a particle cannon that is firing these particles that bounce nicely off the terrain. There's sparks all over the place, and there are explosions where it hits. And and the frame rate here, even with all this stuff going on, is still pretty good. And of course, if we do this in the dark, it's much more exciting. Where are we? Here we go. Particles coming at us in the dark. So I'll stop that, and I'm going to stop sharing, and I'm going to end recording, and I'll see you all in class. The point here is particles cost something. Beware of too many. I'll see you in class. Bye.